You are welcome to the Normal Physics channel and the Physics Practicals. Today you are going to perform an experiment concerning Ohm's law. It is a very simple experiment, but what we need from you is just to correlate, think critically and correlate what you have learned in the class and what you have seen in the real life situation. Okay, so in this experiment, we have given jockey, ammeter, a dry cell, a meter rule, and the resistance of a wire. Wire here we have given has a resistivity properties of 12.6 ohms per meter. Okay. I think you know about the relationship between the resistance of a wire and cross-sectional area of a wire together with the length of a wire. Also, you have the knowledge of meter bridge, potentiometer. Also, you have a knowledge of a circuity formula in the Ohm's law. So you need to organize those to have the e.m.f and the internal resistance of this dry cell. Okay. So the circuit here have been connected concerning with a circuit diagram shown in the question paper. This is our question paper. It says that you are provided with a wire labeled Q having resistivity properties of 12.6 ohms per meter, a dry cell, jockey, ammeter, meter rule, pieces of sellotape, and the connecting wires. Proceed as follows. Sketch and fix about 60 cm of a bare wire Q on a wooden meter rule using sellotape with the one end connected in series to a negative terminal of the dry cell, then ammeter and the jockey as shown below. So this is the negative terminal of a cell connected to one end of a wire, while positive terminal of a cell connected to the positive terminal of an ammeter. Negative terminal of an ammeter connected to a jockey. Wire Q fixed on the top of the meter rule by means of a sellotape. So once we make like this one, is circuit have been connected, means that the current is flowing through the circuit as shown in this diagram. Set a jockey of length 5 cm on the wire Q, then record the value of current I on the ammeter. We record a set a current length of wire Q to 5 cm. This is the 5 cm. My reading there, it is 0.60 ampere. Record the procedure B when the length L is equal to 10 cm, 20 cm, 30 cm, and 50 cm. So for 10 cm, here I have 0.5. Then 20 cm. 20 centimeter, here I have 0.3. After 20 centimeter, 30 centimeter. 30 centimeter, I have 0.24. After 30 centimeter, I have 50 centimeter. When jockey is at 50 centimeter, the ammeter reading is 0.14. So these are data which I have obtained from the experiment. I'm going to make a data analysis and then answer the questions that follows. According to my data, I was finding the 1 over I, a reciprocal of I. And the question says that tabulate your results including the value of 1 over I. So this is my table of results. From this table of results, the question says that plot the graph of 1 over I versus L, hence determine the slope and the value of 1 over I intercept. From this data, I have a graph. This is the graph. A graph is a linear graph with an intercept. Structure of the graph, I'm sure that you know it. It contains the the heading, which inside the graph paper. Also the scales, which is we have said that the best scale based on the table of 1, 2, 5, and 10. Remember to indicate the axis with a specific unit, 1 over I in the vertical axis and the L in the horizontal axis. After then, best transfer of points. Transferring of points, we are talking about for example, when you see this point, is it real from the table of results? This is 1.667. Is it corresponding with the 5? Okay. This is 5. Let me find is it a real 1.667? You can see that when you take 1.667 dividing by 0.5, which is my scale, it contains 3 squares, 1 square, 2 square, 3 square, and point 1, 2, 3. So this is correct. It is a point from the table of results. Again, if we can see this one, point to this one. This is 2.0, corresponds with 10. 10 is here, 10, 2.0. And you can do the same on all of the points on the graph. After indicating the points, transferring with the points, then draw a line which contains many of the points. This line known as a best fit line. And the remaining points should be distributed equally or evenly distributed. As you can see my graph here, there's 1 point remaining here and the 1 point remaining here. So this is the best fit line. After indicating the best fit line, then indicate the slope. Slope should be indicated by using the dotted line. Remember to write a right angle at the meeting point there. Okay. You need to remember that these vertical and horizontal axes are very long lines with no end. So show the direction vector after the meeting point, your meeting point there. Show the direction vector vertically and show the direction vector horizontally. And remember to indicate the 0 coordinate. It means that this is 0.0 at the meeting point. 0 horizontal axis, 0 vertical axis. So this is the graph. From the graph, we are going to answer another question. From the value, okay. This question number 2 was said to plot the graph, then determine the slope of a graph and the y-intercept. So, and the 1 over I-intercept. From the graph, slope is given by changing 1 over I dividing by changing in L. 1 over I in per ampere, L in centimeter. So when you read direct from here, this point is 5.85 minus this point here is 3.5. Divide by this point here, this is 40 centimeter minus this point here. If you can read directly, it is 22 centimeter. So here we have 2.35 dividing by 18, which gives the value of slope is equal to 0.131. This is per ampere per centimeter. It is a value of slope. After then, 1 over I intercept. 1 over I intercept, if you can read directly from here, this gives us 0.65. Means that every small square here containing of 0.05. So just you count how many squares, small squares here, then plus this one. You shall have 0.65. This is per ampere. Okay. Question number 3 says that the value of the slope obtained in part 2 determine from the value of slope obtained in part 2 determine the e.m.f of a dry cell. So how can we determine the e.m.f of a dry cell? In order to determine the e.m.f of a dry cell, we need to have the equation of the graph. The equation of the graph. So the equation of the graph from the Circuity formula. From the Circuity formula, it says that I is the bracket R plus R small. Where is it from? As you can see our diagram here, this is the length of a wire, has a resistance R. We have said that you know the relationship between the resistance and the length of a wire together with the cross-sectional area of a wire. So wire has a resistance R. Also a cell has a internal resistance R small. So the e.m.f of a cell is given by the product of the current flowing through the circuit multiplying by R plus R small. So this is the Circuity formula. So E dividing by I is equal to R plus R small. One over I is equal to R dividing by E plus R dividing by E. But R is equal to resistivity times length dividing by area. So here we have 1 over I is equal to resistivity times length dividing by area times E plus R over E. To make it clear, it is 1 over AI resistivity over AE multiplying by L plus R dividing by E. So if you can see this one, it could be the equation of a graph. A graph of 1 over I against L, where R over E is an intercept of a graph. So the slope of a graph corresponds with the resistivity dividing by AE. So from the graph, slope is equal to the slope of the equation, which is equal to resistivity dividing by AE. We are looking for the e.m.f of a cell. So e.m.f is equal to resistivity dividing by area multiplying by 1 over slope. Resistivity dividing by area we have. This is in ohms meter, this is meter square. So meter and 1 meter here cancel out. The remaining is ohms per meter, which is given 12.60 ohms per meter. So here we have e.m.f is equal to 12.60. This is ohms per meter multiplying by 1 over slope. Slope is equal to 0.131. Remember, it was per ampere per centimeter. So you need to change it into meter. So you need to multiply this by 100 to be per ampere per meter. So this is per ampere per meter. So e.m.f of a cell could be 0.960 volts by using your calculator. So after having the e.m.f of a cell, the question says, that use the value of e.m.f obtained in part 3 and the value of 1 over I intercept obtained in part 2, determine the internal resistance of a dry cell. So from the equation, the internal resistance of a dry cell can be obtained from the intercept of a graph. So 1 over I intercept is equal to R over E. 1 over I intercept, we had 0.65, this is per ampere, is equal to R dividing by 0.960 volts. So therefore, the internal resistance of a cell is equal to 0.65 per ampere multiplying by 0.960 volts, which is equal to 0.624, this is ohms, which is approximately equal to 0.60 ohms into 1 decimal place. The final question says that comment on the reality of the value of internal resistance obtained in part 4. In reality, we have the internal resistance of a dry cell is equal to 0.5. So what makes this a difference? So maybe the sources of errors can be the factor which are affecting the e.m.f internal resistance of a cell. First of all, the cell used. For my case, the cell used, it was it was old one. So maybe it can cause the source of error. For this value of e.m.f used, it was 1.1. So 1.1 in the experimental, I have 0.96, so approximately equal. And the internal resistance, when the cell is old, means the internal resistance increases. So that's why maybe I have 0.60 ohms. 0.60 ohms. Also, sources of error can be also the deformation of a wire. Wire is not uniform, maybe can cause the sources error in the experiment. Another source of error may be due to the parallax observation. When I was taking the value of the length on the meter rule, maybe it can cause the parallax due to the observation. So thank you for watching. Don't forget to subscribe for more videos.